My name is Shuai Wang from University of Illinois at Chicago. I work with Professor Bin Liu, and the title I present today is called the Targeted Topic Modeling for Focused Analysis. Here's the outline of my presentation, and we will go to the first part, introduction. So the task of my job is very easy to understand. First, given the corpus of a broad domain, we assign a target aspect, and we can call it just target for short. And we want to find those topics that are related to the target aspect. Let me give you an example. Let's say we have a collection of tweets that crawl from Twitter about e-cigarette. E-cigarette means electronic cigarette, or we can just call it e-cig for short. And we assign a target, say children. That means we want to know what people talk about children in social media about cigarette, e-cigarette. That means we want to know what people talk about children smoking e-cig. And we can find different topics about this aspect. For example, people may talk about their concerns about children smoking e-cig. And people may also talk about the regulation, how the government made rules about the children smoking e-cig. So this is a topic that related to our target children. And this problem also appears in other domains like the Amazon online reviews. Let's say we have a collection of documents about camera, and we want to know what people talk about the target screen. And we might find different topics like picture, the first one, because picture show up on the screen, right? The second one is menu, because people will also use the screen to adjust their setting, like the ISO, something like that. So those two are actually the related topics to the target screen. Now, let me give you an official problem definition. That is, given a corpus C, and we want to find those topics to our target. Notice that the target in our work is represented by some words. Because we want the system to find something for us, right? We need to assign something that to let the system know. And these three colors represent different definitions. The most important one is the target. Because for our paper, know that the aspect or the target is different from topic. There are two different definitions. And we will represent our target by assigning words, just like children. We will use the words like children or kids to represent this target. And that's the idea. Now, as we are clear about our problem, the question is how to tackle it. We call it focus analysis because we just want to find those topics that are about our target. As we all know, a common approach to tackle this problem is to use topic modeling, right? So let's talk a little bit about topic modeling. Like LDA model, it is a traditional topic model that can find all topics about the domain e-cigarette. For example, we have the topic like children, health, and vape. And notice that LDA or other related models, they are fully analysis model. If we just use it to tackle our task, it might have some problems. And the issue one is that we do not know all keywords. We may know some keywords at the very beginning, like children and kids, but we might lose some important words also, like the young, or youth, minors, boys, that we don't know. That if we do not know this keyword, we might lose some important topics. This is the issue one. Issue two, we may not find topics about some targets, because for a collection of documents, it contains some popular topics, popular aspects, and it also contains some unpopular aspects. For example, the weight. Like the corpus of the camera, we have the topic model that generates 10 topics. It may talk about the lens, screen, picture, or other batteries, something like that. But we cannot find anything about the weight because the topics are dominated by the popular topics. And another reason is that people always express their sentiment or opinions in an implicit manner. Like we will say that the battery is very heavy or the battery is very light. And in this way, we actually find nothing about the weight. In this case, we do not find any topics for some aspect like weight. That's the idea. And this is the issue two. And we also have other issues, like if the topic numbers are very small, even if we want to find a frequent aspect, like children, we still find nothing because, like this, the topic 3, all the words about children may be grouped together because the topic number is small. What about we increase topic number, like 50? In this case, we generate a lot of different topics. But how to get the topics related to children as what we want? The first approach is that we can use some manual inspection that we just manually check every topic one by one from topic 1, topic 2, topic 3, topic 4, until topic 50. But the problem is it might be a bit labor intensive and time consuming. So another strategy is to use some search keywords to locate the topics that we want. For example, we have the keyword like children and kids, right? We can use it for some search, and we just focus on the topics contain these keywords. And this is another approach. But the disadvantage is very obvious that we lose other topics like young and minors. So this is how we want to address this problem. First, we want to do the focus analysis. That is given a target, like children, we want to find the related topics. But existing topic models have such problems like the issue 1, issue 2, issue 3 that I introduced before. So we designed a new model to tackle this task. And we proposed a new model called the Targeted Topic Model, TTM. It can directly discover related topics, just with limited keyword like children and kids. But for this model, we can identify all related topics, even if we just have some initial prior knowledge about the target. For the technical part, there are most two important techniques. The first one is called the aspect sparsity. Here we have the document aspect sparsity. It is reported in some previous work that in short text, it usually focuses only on one aspect. So in our case, we can imagine that a tweet or a sentence from an online review will just focus on one aspect. Let's see the red sentence. It mainly just talks about children. Maybe it is not a perfect assumption, but it holds good in many previous studies, and we just follow this work to maintain the document aspect sparsity. So in our work, we call a tweet or a sentence as document. On the other hand, we also have the targeted aspect sparsity. This one is very important, and the observation is found by the intuition that the target aspect, for example, children, is just only one aspect that discussed in the collection of documents, right? The collection of documents, they talk about children, they also talk about the health and vaporizer and elderly. So among them, the target aspect, children, is only one of the aspects from all different aspects, including the targeted or non-targeted. The idea is that the targeted aspect, compared to all aspects, it is just a small one. It is only one part of all aspects. So we believe that the words for describing the target aspect is in a small size. That means the size for the discriminative word may be in a small size. Meanwhile, for the non-target aspects like the health, elderly, and vaporizer, they together has almost non-sparse words equaling to the vocabulary. Because for those non-targeted aspects, they can talk about everything, right? Like the elderly, like the health, like the vaporizer. So the non-targeted part is almost the same as the vocabulary size. And we want to impose this constraint to our model so that we can find the discriminative words for the targeted aspect. That's the key idea for the aspect sparsity. And the second important technique is we jointly model the document relevance with the aspect sparsity. That means a document has two status. It is relevant to our target, or it's irrelevant to our target, right? But notice that a document is essentially represented by words. So if we can find representative words for the target, it can also help to find the representative document or the relevant documents. And we want to jointly model this relationship in our modeling. And let me give you an example of understanding. We still use the targeted aspect, children. And as we have the keyword children, there's 3 sentences. And at the very beginning, we know that the document 1 is relevant, that we give it a tick. because it contains the keyword children, right? But we do not know the document 2 or document 3, whether they are related or not related. Now, we know that smoking or other words in the same document, they can be related to the target children. But in this case, the word smoking is not discriminative enough or is just too general because it can also appear in other non-target aspects like health, elderly. I can also say that my grandma loved smoking e-cig. And I can also say the smoking is not good for health. In this case, the word smoking is widely used in other non-targeted aspects. So it is not so discriminative enough. Let's see another candidate word, gateway. It is actually more discriminative than the word smoking. It is because people may use it to express the children start smoking from the very beginning and then they go to the area of e-cig. But it might be unusual or weird to say that my elderly grandma starts smoking to use the e-cig as a gateway. So my point is the words like gateway may be more representative to the target children. And we want to find those words because as we find those words, it helps us to better define our topic and our target aspect and help us to better find the relevant documents. Let's see an example. Now, as we find the discriminative word gateway, it helps us to identify the second document to find it as a relevant document. In this case, we can also find that the words in the document 2 like kids are also related to our target aspect. So the point is that on the right-hand side, we can better model the relevant documents. And on the right-hand side, we can better find the discriminative words by imposing the constraint using the sparse modeling. And that's the key idea of the targeted topic model. And here is the plan notation. And it might be a bit complicated, so I will just highlight the most important part for you guys. And let's look at the X and R. X is for indicating whether they have the keyword like children. As we know, the children is in the document 1, so the R means the relevant status. We can see that document is relevant. But for those parts who do not have any keyword, it can be relevant or irrelevant, right? So the model will tackle this issue. And for the red part, it is for representing the sparse modeling to find the discriminative words and also find the focus word inside the topic that related to our aspect. That's the key idea of this model. And here's the inference of the model TTM. And I use git sampling, and I will not go to all details about this. It's just like iterative sampling. We first sample the relevance of the document, and I sample the discriminative words, and then I find those topics to the target aspect. And then I find those words for the topic to the target aspect. And that's just like the basic idea, and I will not go to the details. And I will instead give you some experimental result, which is more interesting to give you a better idea. For the experiment part, I use 5 datasets, and 2 of them are from Twitter, and 3 of them are from Amazon reviews. And on the right-hand side, there are different targeted aspects that to use for testing our model. And here's the baseline model for comparison. The first one is LDA, the traditional topic model. The second one is very interesting. It's called LDA PD. PD means partial data. That means, for example, we have 1,000 tweets, right? And there may be only 200 tweets that contain the keyword children. And I will just extract those 200 tweets and run topic model to see whether we can generate a good result. And the result turns out that it's not bad. It is not bad because we rule out a lot of noise that do not contain the keyword children, right? But it also loses the information like the sentence contain the kids, or minors, or boys, or girls, something like that. And because the data set becomes smaller, topic model may generate not so coherent result for us. But this is a very strong baseline in our experiment. We find that. And let's go to the third one, SSD-LDA. It is a basic model for implement the sparsity. And the DS-LDA, the fourth one, is a double sparsity topic model. And we implement the document topic sparsity and topic word sparsity. Notice that both SSLDA and DSLDA do not tackle the issues of aspect sparsity and the target-oriented, like the TTM does. And for the table, it means that for the evaluation part, we will evaluate the top words of every topic, one by one, from topic 1, topic 2 to 15, sorry. And here we show the result. We use the precision at 5, 10, and 20 to give the qualitative evaluation. We find that the TTN achieved the best result. But as I mentioned before, LDA-PD that use the partial data also give a not bad result. But the disadvantage is that they lose some important topics, and the topics they generate is not that coherent. For the SSLDA and DSLDA, they generate poor results mainly because they are not target-oriented. Maybe they have sparse words in a topic, but this topic may not be related to our target. So that's why they have poor results. And we also have another setting, the experiment 2. That is, now we increase the topic number. Say we have 50 topic number. And in this case, we use the search strategy to evaluate the model. That is, we have the word children or kids. We will use this as the anchor to locate the topics that are related to our target. In this case, we will filter other non-targeted aspects, right? And we also compare with this model as our setting 2. And we also show better results by the precision at 5, 10, and 20. And let's see some interesting sample results. Following the previous example, we want to know what people talk about children smoking e-cig in social media. And we find some different topics. And let's go to the first one, fears. Why our model can generate better results? One reason is that we can find the reasons of the children smoking e-cig. That's the reason can better express why people concerns or fears, or express their fears for children. For example, we find the nicotine, and the increase of data and cells may be the reason that people express their fear or concern. And we also find that the gateway, our parents may worry about their children entering the area of smoking e-cig. These topics are more coherent and can give you better results and better reason about why people fear. And let's go to the online reviews from Amazon. We have the domain camera, and we first target at screen. And we can find that we find the picture and menu and image. Those are the topics related to screen because the picture shows on screen, right? And we can also adjust the setting via the screen, and the image is also related to screen. And another interesting one is the weight. As we mentioned before, it is a not so popular aspect. And we can generate a not bad result like the lens, battery, because people always complain that the battery and lens are very heavy. So this is a very two important topics that we can find. And we also find the topics called carrying, that people express their feelings when they carry something very heavy. So they are all the topics related to the infrequent aspect, weight. Okay, and let me draw a final conclusion about this work. At the very beginning, I explained the objective and the task of our focused analysis, and given a target and aspect, we want to find those topics related to it. And we also show the motivation of our model because the traditional model have some issues like issue 1, issue 2, issue 3. And we propose our model and we compare it with some state-of-the-art models to show its effectiveness. And that's all for my presentation. Thank you.
Question. Can you tell us a bit about how you generated the data sets? Obviously, you need to create some ground truth, right, for these experiments, right? So these are non-standard data sets because you do this focused search, right?
Sure. Yeah, that's a very good question. And notice that the last author, the Sherry Emery, she is actually a health scientist, that she wants us to do this task for them because they collect some data for the e-cigarette. And they want to know what topics are addressed about children. but they do not know what to do. So they ask us to help them. And actually, that's why we cooperate with those health scientists. And we generate those topics for the evaluation part. We will ask those domain experts to adjust whether the top words on the top 10 or top 20 are good or not. And we didn't show the model name. We random all the models and asked them to evaluate the word quality of every topic generated by every model. So it's like we ask some domain experts for the judgment part to us.
Okay, yep. Thanks.
Perhaps maybe I misunderstood something, but I'd be curious what if your domain is, say, all tweets, and you're interested in, say, a particular show which may have many characters associated with it, many terms associated with it, and you really want to pull out, say, tweets that are related to that or some sub-aspect of that. Mm-hmm. Well, I guess the question is, would it work well for that?
I'm sorry, what's the question?
So if you're instead, rather than being in a specific domain, say camera reviews,
yes.
Instead you had your whole, say, data set of tweets, and you're interested in a particular, say, instead of cameras, a show which may have many terms correlated with it, but you don't know what the right terms are.
Yes.
Would this work well for that?
Yeah, that's a very good question. So that's why we want to impose the sparse coding, right? Let's say we have a target aspect like screen, and we want to limit that representative words in a small size. In that, no matter what corpus are, we want to find those words that are most semantically related to the target aspect, but do not relate to the non-target aspects. We want to find those words. On the one hand, we can reduce some noise from those non-target aspects, right? And from the other side, we can use those discriminated words to find other documents that even do not have the keyword like children, but we can still find those documents for better modeling. And another answer for your first part is, when we do the experiment, we will collect the document from one domain. For example, for the web page about camera, we will crawl the data that all about camera, treat it like a domain, and we will also crawl the data, because when we extract the data from Twitter, we also have an input word to extract those tweets, right? Like e-cigarette, I will input the e-cigarette as the word to extract, to construct the corpus for e-cigarette. But you raised a good question. If we might combine different domains together and can use some aspects to distill all related topics, that might be a very interesting task. And yeah, it might be a future direction. And thank you for the question.
Okay, we can have one last quick question. In the meantime, I would like to ask the next speaker already to set up for his presentation.
Okay, just thanks very much, and this is very interesting. I just wanted to ask briefly, have you done analysis of the tail of keyword search? How complete of the total data set of intent do you think you're covering in terms of those searches?
So the problem is how to recover the...
Yeah, I mean, I have some experience doing this from a manual standpoint, and that we know that search keywords can be very messy. Sometimes it's actually a couple of words, 2 or 3 words that, as a combined context, are what matters. So I'm just curious, first, if you're able to do phrases with this analysis, and second, I would just be interested in suggesting that I'd be just curious what % of full intent that you're actually able to capture with this. Just something to experiment on.
Yeah, the suggestion is that we only use a small set of reliable keywords at the very beginning. Like we want to find something about children, right? We only use that like kids or children at the very beginning. Because that's the advantage of a model. Even if we assign some confident words, that it can group the most discriminative words to it. Because we have the sparsity, right? We want to constrain that the words that related to our target is in a very small size, that we can reduce some noise. So my suggestion is just use some reliable words at the very beginning. Yeah.
Thanks so much.
Yeah, no problem.
Thanks once more.